this racket here stopped working. A lot of people would throw it away, but today we're going to use this device to understand two circuits very commonly used in electronics: a capacitive power supply and a circuit that generates high voltage, all using a simple device that many people have at home. Hello everyone, welcome. All right, we've already opened it and let's see what's inside. This board here is quite simple. There are a few components, but there's a lot of interesting stuff happening here. Let's just solder these wires, remove all the components, and assemble the circuit again, explaining each stage of its operation. The idea here isn't just to fix it, it's to truly understand how this circuit works. Music! We removed all the PTH plated through-hole components, leaving only the SMD surface mount components, which are these underneath the board. We have 4 resistors and a bridge rectifier. So, let's start with the power plug. 110 or 220V comes in here. In series with the plug, we have this polyester capacitor. Music, this LED indicates when the power supply is plugged in. This energy is not for powering the high voltage generating circuit of the racket. It's only for charging the internal battery. We have the power input at these 2 points. Here, 2 resistors, and LED, the bridge, rectifier, and on the other side of the board here, we have the polyester capacitor. These components together form a capacitive power supply. It's simple, cheap, and very common in low-cost appliances. There's no transformer here to reduce the voltage. The component doing the work here is this polyester capacitor. It doesn't reduce the voltage. It limits the current. Did you notice the difference? The current is limited, but the voltage remains high. This resistor in parallel with the polyester capacitor is essential for the circuit to function. It only serves to discharge the capacitor when we unplug it from the wall. So, when plugged in, the current passes through this capacitor and arrives here at one input of the bridge rectifier. The other side of the plug goes directly to the bridge rectifier and also to the resistor that powers the LED. And here, at the output of the bridge rectifier, the alternating current AC is converted into direct current DC. At the input, we have alternating current. At the bridge output, we have direct current. A big warning here. This is dangerous. We have high voltage. This is the battery that came with the racket. I've already checked it. It's no longer holding a charge. I'll get the multimeter to show the remaining voltage on the battery. See? Very low. Let's go back to the board to connect it to its charger. We need to be very careful here. Negative of the battery to the negative output and positive of the battery to the positive output of the bridge rectifier. This high voltage goes directly to the battery. Since the output current is very low, this voltage ends up dropping considerably. Even so, this is not proper charging for the battery. With a charger like this, it almost seems like the intention is to destroy the battery because there is no control here. This type of battery is more tolerant and won't explode. But this explains why its lifespan went down the drain very quickly. So, the first thing we'll do is eliminate this charger. We'll remove the power input wire because charging will no longer be through here. And we'll also need to put a more powerful battery here to last longer on a charge. Now let's move on to the most interesting part of the circuit. The circuit that generates high voltage. Here we have a D882 transistor, a small transformer, an LED to indicate the operation of this part of the circuit, an on-off switch, and a press button. These are the components on the primary side of this mini inverter. And also in these 1.2 ohm resistors that limit the current and help the circuit operate stably. This one will work with a transistor, and this one here will work with the LED. Music. Notice that the circuit is simple, robust, and well-designed. An important warning. Even though it's simple, this circuit generates high voltage. So, be careful when handling it. This is not a circuit for the curious. The problem isn't here. The weak point of this type of device is the battery and the way it's charged. Music. This battery here is simple and can't handle this type of charging for very long. The solution is to use a better quality battery, but simply swapping the battery isn't enough. It needs to be charged properly. So this power supply here will be replaced by a real charger. Music, and here we put a small module to handle the battery charging. So, we use this simple device to understand capacitive power supplies, battery charging, and get an overview of how this type of device generates high voltage. This circuit on the screen is responsible for generating the racket's high voltage. Today's idea was to show how it's assembled and what the role of each part is. The detailed operation of this circuit, how it oscillates, how the transformer works, and how the high voltage is formed, step by step, that's a subject for a dedicated video. So now I want to know from you. If you want to see the complete explanation of how the circuit works, leave a like and write it in the comments. That way, I know it's worth bringing a video just about that. A lot of electronics end up in the trash unnecessarily. Sometimes the fault is simple and the learning is immense. If this kind of content helps you truly understand electronics, subscribe to the channel, leave a like, and we'll see you in the next video. May God bless us.